Hello, we are here to present our final project for CSI 2290. I have Ledja, Rami, and myself, Anna. We did the online voting system project. Little introduction. The purpose was to create a voting system for a small community or organization. We chose a small sample size of 20. And then we had to implement a system where voters can vote for a candidate and the results are stored and displayed. And that comes directly from the description for the project as handed out in class.
Okay, so for data structures, we ended up using a bunch of different components, like linked lists, vectors, stacks, hash tables. The linked lists were used to store each voter's information, consisting of their names and their addresses. The vectors were used to implement the hash tables. There were two vectors representing two hash tables, one for the voters and one for the candidates. And then also stack was also used to implement the voting system to allow the voters to undo their votes as well as submitting it.
So for the features, we have a console-based user interface that prompts the voter to register by entering their first and last name and as well as their email address. For the registration, we displayed the name of the candidates and their information on the console so that the voter can see the candidate as well as a small little biography and they can make an informed decision on that. And then we also made it to where the voter will be able to undo their vote if they by accident chose the wrong candidate. After a voter casts their vote, they'll be able to see the current tally of the results, and then it'll prompt the user to register another voter or display final results. After it displays the final results and determining the winner, it'll output all of the voters' information for confirmation of who has voted.
So our approach that we decided to go with, we decided to have students vote for their favorite professor. We have 4 options. And we assumed, again, a small sample size of no more than 20 voters. The professor's name, department, and short description pertinent information were stored in a linked list, which was then hashed to the candidate's hash table using the ASCII value sum of the letters in their name. The user is prompted for the voter's name and email address, and then a Boolean flag of false is automatically initialized to indicate that the voter has not yet voted. This information is then hashed to the voters table using the ASCII value sum of the letters of the voter's name. And then the information of the voter was then printed to the terminal screen along with their hash index. And the candidate's information is then printed to the terminal so the voter can make an informed decision. The voter was prompted to choose a candidate for their favorite professor. Voters then prompted to confirm or undo their vote. If they chose to undo their vote, they're prompted to vote again, and the vote is not recorded. If they choose to confirm, their vote is added to a stack for that candidate. Their Boolean flag is changed to true to indicate that they have voted, and the current results are displayed by determining the size of each candidate's stack. Finally, the user is prompted to either register another voter or display the final results. If the user chose to register another voter, the registration starts again. And if the user chooses to display the final results are displayed, the winner or winners in the event of a tie determined, and a list of all the students who have voted is printed out for confirmation. Some little notes on the linked list. We prepended new nodes instead of appending. And this was partially because it's big O of 1 to add a node to the beginning, but it's big O of n to add a node to the end. And we knew that we wanted to make the hash index the head node to make it easy for storage in the hash table. So we decided to prepend instead of append to keep costs down. We also created a special class to accommodate nodes of different data types, such as string and a Boolean.
Okay, so just a little side notes for the hash tables. We ended up creating 2 hash tables. Size 11 for the candidates, just because we have 4 candidates, double that one and go to the next node. That equals out to the 11. And then size 41 for the voters. That's mainly because we approximated 20 voters and then again, doubling it out and moving to the next node that will take us to 41. And then we initialized it by using vectors to store the hash tables. The hash tables index then became the head nodes of each individual's linked list. And lastly, the hashing was performed using the ASCII value, sum of the individual's name.
We use a stack to keep track of every vote for every candidate. We used a push one where it would go on top of the corresponding or on top of the candidate stack after every voter's confirmation. The size of the stack was used to determine the results. Some extras that we have were that we used on the program. We also accounted for any ties that were between the candidates, and it printed a list of all participating voters towards the end.
That's it for the presentation.
Thank you.
And now we'll go over to the live demo. You guys still see my screen? Okay. So for the live demo, first it asks for the user's name, and we will just make up some names and some email addresses. So now we'll scroll up just a little bit. You can see that the voter has been registered, and then we display the registered voter's information. You can see the name and their email, false because they've not yet voted, and then where they are in the hash table. Finally, we can see the candidates. So we have 4 candidates for favorite professor, along with their department, and then a little bio about them. It says, please select your favorite professor by inputting their candidate number 1 through 4. So I'll select 1, and then it confirms who I selected. It says, this is a valid selection. Proceed with vote. Do you confirm your vote? And I will say, yes to confirm. Now it says, thank you for voting, and it asks us if we want to register again or display final results. And you can see just above that, that shows the current vote counts for each professor. So we will choose to register someone else, just so we have a little variety here. And again, you can see the voters' information here and where they are hashed to in the table. Again, we can see all the candidates, and it says, please select your favorite professor. This time I think we'll pick 2. Do you want to confirm your vote just to show that the undo works? We'll say no. It says vote not confirmed. Please vote again. Please select your favorite professor. We'll say we're going to vote for professor number 4 this time. And this time we will confirm. Now it asks, would we like to register another user or display final results? We'll register again. Did I spell that right? And you can see that the voter's information is here. And all the candidates' information, once again, because this is a different voter, we need to show it each time. This time, we'll vote for number 1. And it says valid candidate. We will continue. And this time we will say, we just want to see the results. Oh, and you can see that the current vote counts has updated. So this time we just want to see the final results, which means we are done voting. So this tells us final results. So these are all the vote counts and it says, this is the student's favorite professor. And then it lists out all the following students who have voted by index. And you can see that it's changed our Boolean flags to true, indicating that we have all voted. And that is the end of the program, because that is the end of the vote. If we had more students, we would have continued to go through the registration process, but only up to 20 students. There is an error built in case we exceed the hash table size. However, that was not the case here, and we again chose a hash table size of 41, indicating, we had to assume 20 students, double it, and go with the nearest prime number just to make it easy. We also could have just used an absurdly large number. That would have also worked. But that is the extent of a project. Thank you.